if you can see everything. Also check to see if he wants to do a mic check.
Next question is long flight. It's not too bad. Yeah, 12 hours. Yeah. I'm based in New York. I conversation with one, right. But then I did my BA at Sydney. Yeah. My kids are in Sydney. Yeah, it's quite fast. Yeah. I can go all the way around. It's almost like going around the other end. I just did this when I was at the conference. I think that was one thing. Yeah, and then it was always driving to Formula, yeah, but the office, yeah, so go around and just go around the world. Yeah, you know, I said this is about passive. If you can just do that trick. I'm not sure about which is actually the reason why I'm here. It's very sharp. So now I'm trying to move on. South America. My next destination is right. Then we go there, maybe this part. Bloomberg has a big office. Right now, we got a story from New Zealand. Why they were building excavation site and put the offices around. Yeah, it's yeah. But it sounds pretty much every time you drop a tower or something in the city, it's yeah, rather than remains or the right, the fund planes and really all the time. Something or other. So the whole thing is that a couple people want they were giving a slow in feeling for that. Which is they found all that stuff and then the cross rail. Some areas will potential areas when we start talking about capital league, but with glass. Area or do something based on this is still some nature. Save some of it, yeah. Then save some of it on the conditions is right. Are you in London or
sort of competing cookies?
South Coast. South Coast. That's right. My boss is. So I don't know if it's kind of from along there. I think that's what both IETF.
Let's give it 2 more minutes here. We're not in the hyper aggressive.
Yeah. I mean something now, but you know, I'm working on I've done some of the, I usually do the definitions and products. So, that's stage. Yeah, we actually have offer DAP board, running protocols, we also do DAP on anything else. How is it here? So that can hit. Yeah. We have big user of it. Yeah.
I'm sorry? How was that? Yeah, no. It's BFD and BFD small.
That was 20 years ago. So.
And as Jeff said, there's some cookies up there.
Yeah.
Good, thank you. I've had enough.
Yeah.
Of course, you got your shirt today. Not today, before.
That was last night, yeah.
Yeah, it's nice down there. You see all the small solution platforms there.
And you both play guitar, if I remember right.
He's cutting the
Yeah, he only does two.
Right.
I think
And complaining about his daughters.
Yeah.
Also, maybe watching.
No.
About 45 minutes. When they make some live, they don't always do the two shows at 7.
Right.
Then tonight.
get started. I think this is about what guys are going to do. It's very short. Effectively, lots of updates and one real presentation that's hopefully more feedback than not. So if we're here, I'll just say this to everybody. Good afternoon, everybody. This is BFD. This will be a relatively short working group update, so we'll hopefully return you to productive work sooner than other working groups. This is the note well. By speaking here, you are making contributions to IETF, so please make sure to take a look at this and what its implications are. Again, we have a very short agenda today. A lot of these things are just updates trying to close out things to get documents published. Most of these things are updates. The item at the end, BFD for large packets, is queued up both as use case motivation and also as an attempt to get the working group to discuss things a little bit and see not only do we want to take up this work, but what other things we want to do in this workspace. So we have several documents in ISG last call. The BFD Yang model and the two BFD multi-point documents are working their way through the ISG. That has proved a more entertaining exercise than it often is. Some of the feedback has been special, we'll call it that. But we'll be getting feedback about that in just a little bit. We did have a working group last call request for the authentication documents, covering the secure sequence numbers, optimizing authentication, and the BFD stability document. We received minimal comments on these. Greg Mirsky did raise some technical objections on these, but it is our belief that that has actually been addressed. We're at this point pondering how to proceed. We would like to get a little more feedback on these things before we do progress them. We do realize that authentication is a topic that has tended to traditionally get minimal amounts of feedback, so we may look for additional feedback elsewhere. In terms of progressing it.
I'm sorry. So Greg actually said on. Greg just said on Jabber that he feels his comment was not addressed. And we have Mahesh who just entered the room, so that's perfect timing.
So, Greg, is there anything specific you wanted to raise by us or have Mahesh respond?
Okay, may I use the mic? We had the discussion with Ashish, and the question, just to remind everybody, the question is that optimized authentication has several modes. One of them envisions periodic use of authentication. So my question was that if once their session is upstate and authentication validation fails, what happens then? Because if we have one authenticated packet followed by a series of non-authenticated packets, and those are validated, then based on 5880, the session's still in upstate. But logically, if authentication fails, so we want to do something.
Right, and I think my response on the mailing list, Mahesh Jetanandani, was that you want to view this optimized authentication as not changing the protocol in any way, but specifically to the question of what happens when one packet in an upstate gets authenticated is marked for authentication, and it fails authentication. So the protocol says that it has to have not receive 3 packets or if that was the timeout set, then only will the session be marked down. So to the specific scenario that you're describing, where one authenticated packet fails authentication, but the subsequent packets pass, I believe the session will stay up.
I agree. Per existing specifications, that's what will happen. But then the question is, then what's the purpose of using this periodic authentication if there is no impact on the state of their session? Because if authentication fails in up state, there is no impact on the state on their BFD session.
That is correct. So I think the second point that I wanted to make, which I forgot to make, is that, well, actually, let me come back to that. To your point that yes, today, and not if that authentication failed, then what is the purpose? The idea, and it wasn't even actually in our original proposal, was that we might want to authenticate every infrequent packet for the simple reason that if there is truly a man in the middle that is trying to manipulate the authentication or manipulate the BFT, that this particular authentication will fail. It's an indication that of maybe there is some either corruption of the packet or an unauthenticated packet being sent, but by itself, it doesn't affect the BFD session.
Right. So basically, we capture something, we detect something, but then we don't signal that, and we don't take any action on that. So that's where I see that there is some gap in logic of the proposal. So BFD is intended to monitor continuity of the path. Security is to protect that, so to exclude it to be used as attack vector. If we see that somebody might be trying to do something with a BFD session, then should we somehow indicate it to the far end? And that might be is that okay, I see 2 options here how to address it. One option to say, okay, well, periodic authentication doesn't really help with anything, so let's remove it altogether from the specification. We only authenticate when the state changes. The other way is that to say, okay, if the authentication fails in periodic mode in up state, that should be interpreted as defect detection.
This is Jeff Gregg. So one possibility to maybe just clear up the procedure a little bit, the goal of the periodic authentication is to catch the man in the middle and the sort of silent replays. It's my off-the-cuff belief that we can make this work as I think we're discussing, simply by doing the periodic authentication and make sure that we send the detection multiplier's number of packets in the authenticated state. If we do that, at least that number, that will cause the session to go down and should satisfy your concern, I think.
I believe that will require to use PF procedure to changing detect multiplier.
Sorry, not change the multiplier. So the example being if the detection multiplier is 3, this just simply means we send 3 authenticated packets rather than just the 1, and that's enough for the session to fall over.
Yeah, okay.
All right, fair enough. I think we can certainly make that change.
And Jeff, just to clarify, this is just on state change, right? Still nothing else?
No, it is the
This is for
periodic.
the periodic. So the refresh on the document. The whole point is that we are largely running with authentication turned off. We are using the secure sequence number mechanism to try to provide a little bit of additional protection from man in the middle. This was recommended by our security guys. The periodic polling was also recommended that in the middle of your session, if you're not making a state change, just periodically send out some authenticated packets to make sure that the session's really up and somebody's not keeping it up by a man in the middle. I think the majority of people who work on BFD implementations consider this a little bit of a weird bit of thinking, but that's what our security guys are suggesting. And
Somebody agrees with the proposal, Jeff.
so Frank has some canines that do something with the security area. But I think the only thing that really we adjust was simply make sure that we send out enough packets that are authenticated that,
Fair enough.
that impacts the session.
Yeah, I think that we can say that in periodic mode, sender must send number of packets equal to detect multiplier.
Okay.
And there's no benefit of doing that on state change? On state change, just going to be just one authenticated?
Well, it will always be, okay. Every state change packet has to be authenticated. Now, if one fails, then the subsequent one will probably be, resend in that case. So it's that anytime you indicate a state change, you have to authenticate.
And I think sort of for pedantic's sake, when we're making the state change, we do have to say that we are setting the authenticated field for at least the same detection multiplier number of packets. And if we're doing a poll sequence, that we need to make sure we do it for whatever the new detection multiplier would be, whichever one is longer.
That's correct.
Okay. So continuing through things. The next steps on these, it sounds like we've perhaps just addressed the microphone, the outstanding issue. So we'll take this back to the mailing list and see if we can maybe close this back up and then maybe progress these documents. Speaking of progressing documents, BFD VXLAN was adopted recently. Part of the reason that we were holding it back from just simply moving it quickly to publication was waiting on implementations. We now have claims of 2 implementations. A item that is worth flagging in the working group is that Cisco has published an IPR notification against this draft. I encourage you to read the actual IPR, but the short summary is it is the very standard Cisco mutually assured destruction form of IPR. They basically say you can use it as long as you don't assert patents against them. They won't assert it against you. But again, consult your own lawyers. They also provide other options. Given this, I think we may be at the time that we should consider doing a working group last call against this one. So we may kick that off after this meeting is done. Just to get a sense of the room, who here in the room has read the VXLAN document? I see one show of hand. So again, we'll take this to the mailing list, and we also will attempt to get NVO3 to pay more attention to this again. We also have had some discussion at the prior IETF over draft Chen BFD unsolicited. We got a short presentation on that. Commentary we'd received was effectively that some implementations basically do this already for static routes. And people seem to be surprised that not everybody does this. So this is less a matter of, could this be done? We have existence proof that this does work in some extent already. And the discussion really was that there isn't much in the way of protocol change that's necessary. This is mostly an piece of implementation advice. The discussion I think that we've had to this point is that we should publish it as an informational document, which means we need to go through an adoption cycle. Jeff, microphone. Yeah, and Jeff's point was that this does need to go in the Yang model. I did provide commentary about that to the authors. The stuff that I think had been discussed is that some of these types of changes may effectively cause a bit of the thing that we were trying to actually get through the ISG right now. So this will be interesting. So Anchor, still looking for this to go through adoption?
Yeah, if you look at the history of this, really motivated by, I think 1 year ago there was a lot of discussion about this. Basically, how do we do BFD with RAS servers, right? That's where basically you have third-party next hub being propagated, right? There are really multiple options. This seems to be really the simplest solution, and actually a lot of people are not aware of. You actually can do it because people always say, "Oh, this BFD spec requires you to have this bidirectional." Actually, that is not good. So it's either we basically say we can add a couple of sentences in the base spec as a clarification, or we do something just as informational, right? So there's certainly, I think there was a lot of confusion. So that's why there's a value basically to either, it does not have to be here, it can be in the base spec or whatever, basically that's easier. Basically, yeah. Yeah, I think in the document we list basically 2 examples as applications, right? One is really the static RAS. That is sort of is a silly requirement to have both sides to do this only. And the other is really the RAS server, the third-party next hubs, right? So these are basically real valid use cases. So yeah.
And informational document, I think, is where we decided this probably would go through. So if you're okay with things, we'll send out an adoption request after this IETF. We're working through process, and I suspect we'll just end up with a relatively fast informational RFC out of it. For clarification, one of the cases that was mentioned was the route server BFD document, which I happen to be a co-author on. And this does actually simplify, when you can use this, some of the procedure. Otherwise, you end up having to sort of use a bootstrapping mechanism, which is a little bit on the complicated side of things. So progress that.
Yep, sorry. Just a comment on your question regarding the Yang model, Jeff. So we had discussions among the Yang doctors with Benoit a while back is whether when there is a protocol extension, whether the Yang model should be in a separate doc or whether it should be part of that doc, which is extending the actual protocol. So I don't think any decision has been made on that. I don't think any decision will be made globally. But I think for certain changes, we should consider doing the Yang extension, the Yang model extension in the document, which is doing the protocol extension itself.
No, we're certainly willing to help you on that if Yang is not your thing.
So in this case, it's really just a configuration app. That's our interface, right? It's all off.
Okay, another, sorry?
Is there a previous example, the dimension Cisco systems? Is there a previous example the Yang model is described in the extension documents we can follow for the BFD or for other protocols?
I don't think so. I can ask. But as Jeff said, definitely if there's no examples, there is enough Yang experts now to help.
Oh, okay. We can just create a Yang section or something. Yeah.
So here it's a Yang spec for this for BFD complete. It is already. So here this part it's not clear to me, right? Because this is basically the intended standards is informational, right? So where do we specify this one-line config?
Right, and actually that's a valid point is if we're extending the base Yang spec, then that may actually move this to proposed. We're getting our AD shaking his head yes. And that just changes the status of the documents. Otherwise, not a big deal. But your point being that this type of extension's not been done, and to some extent we're pushing the envelope on this. IETF is still learning how to interact with these documents that we're publishing, and as we're finding in other things like our IANA considerations for our module, we're already causing the ISG to have to think about things like name stuff. But Rashad will be giving an update on that momentarily.
Yeah, certainly, I think some of the lines are down.
We want to make this easy. So 5884 BIS, there is still an open task item against this. I had, since the last IETF session, polled the original authors of that, including Kriti, and they are willing to help with the respin of the document. Just as a reminder, this is dealing with the minor clarification for the LSP ping bootstrapping mechanism. Rather was raised by I forget exactly which company. I want to say it was Huawei, specifically about what to do about the discriminator that gets passed back of that and whether LSP ping needs to respond. It's a relatively small thing. The consensus was reached on the mailing list. We just need to get the document updated.
Sorry, I actually missed a comment from Greg. Greg says he supports the last working group last call for BFD VXLAN, and he will provide the necessary support for the comments he gave.
We do have a adoption call also for draft Mirsky BFD MPLS demand. This is a relatively minor document clarifying some of the procedures for BFD in demand mode. What we're doing, the MPLS profile of it. Something I'm somewhat puzzled by, which Greg hopefully you can address, is this is really core mechanisms for BFD, and there seems to be an IPR that's been filed against this. And please feel free to use the microphone, Greg.
Yes. Okay, I'll get to IPR disclosure now. It's much easier. And yes, this is specifically for BFD demand in definition of 5880. So again, it's will be interesting because in our later discussion today, when I report on multi-point BFD, because multi-point BFD does uses demand mode, but it's over IP. So this is a proposal to use demand mode for efficiently 5884.
I don't know that substantially addressed anything, so I guess I will take my comments further to the mailing list.
Thank you.
Okay, and I'll leave this mostly up for people to look at in the slides online, but BFD is a popular protocol that gets used in lots of contexts, and this is a not quite complete list. Things, 2 or 3 things that popped up, including this IETF. One of the more interesting ones that is not written down at the moment is BFD as used as a liveness protocol for the LSVR link state vector routing stuff. I've raised some caveats with the people who are considering that, especially if they're using point-to-point BFD. That will be interesting on its own. And again, please pay attention to these documents, and part of the charter of the BFD working group is to provide advice about the use of BFD in other contexts.
Jeff, if I may.
Please.
Yes, I just want to note that their discussion on VRP use for or use multi-point BFD for VRP case. Their chair decided that results are inconclusive because of the low participation. And I'll appreciate the working group take a look at the draft and use RTGVG list to express opinions.
Okay, thank you. Okay, our next presentation is going to be an update on the BFD Yang model.
Yeah, so this should be a quick update on the BFD model. So this is mostly minor changes which has happened since revision 11. We're at 16 right now. It's comments basically we got from Jürgen, Yang doctor. He did really good job, and from Ayana. So registries and fixed references and stuff like that. So nothing major. Next slide, please. A bit more major. So we had three discussed positions. Two remain to be cleared. The first one, I'm happy that Martin is here, is regarding all Yang modules, just like for SNMP, which or for IANA registrations, they start with the prefix IANA, so IANA IF types and stuff like that. And somebody has raised a discuss on this and picked BFD. So this is not a BFD specific issue, but apparently we have to fix it starting from us, which is fine. So
you don't have to fix it until we effectively get a clear message that you do. I'm still trying to have a rule defined for IETF wide before we change. So you might go through by using INR, but okay. I still need to discuss this with Elisa, and I think that's in any case a discussion that needs to happen in NetMod.
Yes. Yes.
So we're not at the end of the tunnel because that might take long. I'll try to push for no change here.
Okay.
But I cannot guarantee that. In any case, I don't. Since it is not a BFD specific issue, I would clearly would like to avoid delaying the progress of this document on that basis.
Have you discussed with the chairs of NetMod? Okay.
Not yet.
Okay.
So if I understand, Martin, what you're saying is if we were to clear the other discusses, we should actually go ahead and try to publish an update to the draft.
No, you can't. You can't progress. You can publish whatever you want, but I will not be able to approve the document if the discusses are not cleared. One of these discusses is the IANA item. So one way of clearing it is change the name. Another way of clearing it is convincing Elisa that clear your discuss. Let's have a broader discussion across IETF and let's get on with it.
So before you leave microphone, Martin, when do you expect the ISG to gather the talk about this? This obviously is going to require a broader bit of consensus among you guys rather than us.
So it's really a discussion between you, me, and Elisa, because Elisa raised the discuss. So if we manage to discuss and clear and agree with Elisa, then this is not a discuss point. Then and she clears the discuss, we're fine. We don't need a broader agreement than between us, the authors, and Elisa.
Okay. Well, you know where we are, so please grab us if you can.
Yeah. I want to grab Elisa. She's been quite booked recently, but yeah, that's my plan for this week.
Gasp, the IETF chair is busy.
Okay, Mahesh, sorry, maybe this might require Martin to come back, or maybe Rishad, you can clarify how is NetMod involved in this discussion?
Well, because, Martin was describing that we may want something which is IETF-wide. We can't just say, so there were some names which were suggested. If there is a change, NetMod would ideally be involved in that to approve of the name change. That's my take.
I wouldn't use the word approve, but rather the first few words you have, be involved in the discussion
Okay.
as the forum where most of the people concerned by that change can be reached.
Right, and certainly one way to look at this is this is a practice. Now, how do we issue IANA maintain modules? We had procedures that we did for MIBs. I think that we're one of the first documents outside of NetMod that's attempting to do this type of thing for registry. That's what seems to be kicking off this conversation. And once we come to some consensus, NetMod likely would want to update its best practices document.
Yeah, 6087 bis.
Yeah, effectively, in the MIB space, you have a lot of such references. In the registry space, I think there are 3 or 4. The interface one has. There aren't so many documents. So.
The second discuss, which is remaining, is security considerations from Ben. Basically, I don't know if you guys have been following the discussions on the email. Jeff and myself had a quick chat with him on Sunday. My take of this is just some light text would be good enough for his concerns.
Probably.
Do you concur?
I concur. A lot of this just simply came down to I made comments that he was confused by. The general consideration came down to it's much harder to attack BFD that's a client of a protocol that should be attacked the protocol itself. Therefore, we're sort of putting the security consideration in the wrong spot.
And there was a discuss for text regarding the descriptions. That was from Warren, I believe. There was a comment, which I know comments are optional, but in the unpublished draft version, I did address that comment, adding some data nodes, which are like IP addresses and all that in the security considerations. And this hopefully should be it. It's been a longer ride than expected.
Thank you. Moving on to our next presentation. This is you, Greg.
I'm ready.
Despite what the slides say, this is not the MPLS TP CCV stuff. Okay.
Yep. Okay. So 2 drafts going together through ISG last call, and so I appreciate the help and comments from Rashad and Martin. It was very good and helped us a lot to clean a lot of things and think about it. Okay, let's go next. Comments from Bob. Very thorough review. I greatly appreciate his input. Some of it, probably about half of it already addressed. Some we are still discussing. So what is being discussed? The terminology. At IETF, we use connectivity and continuity interchangeably, even though in some other groups, people differentiate them significantly. So the continuity is merely means interpreted as existence of the path, and connectivity is actually when you have a connection, network connection in terms of circuit, and you verify that not only your packets get through, but no other packets get to you. So there is no leaking between connections. And Bob pointed to that, that in the document, there is explanation or note saying that in this document, the connectivity is not used in a transport interpretation of connectivity, but rather as alternative term to continuity. My response was yes, it is how the dictionary constructed at IETF, because the connectivity and continuity being used interchangeably. And if it will help, I'm proposed to change the terminology and switch from connectivity to continuity, and then remove this note. So I haven't heard from Bob yet. Another point was that the timer manipulation that was addressed, that basically that head doesn't have any feedback from the tail, whether tail can process incoming packets. And the wording was added that if tail sees it as overwhelming flow of BFD control packets, it can just close the connection and stop listening to BFD. Inability to authenticate, again, because in multi-point networks, BFD is used in demand mode. There is no three-way handshake, and thus only unidirectional authentication methods are applicable. That was addressed with a proper update to security consideration section. Next slide, please.
Quick pause, Greg. So the Tesla point, I did note on the mailing list, Tesla probably is itself an inappropriate mechanism for BFD multipoint. So you're saying that the current version of the text does include go use Tesla?
No, it's not saying go use Tesla, but at least look at Tesla, and that might give you an idea what to use.
Okay, thank you.
Okay, we had a discussion with the source address spoofing, and again, because resulting from absence exclusion of three-way handshake in the way how BFD multipoint uses demand mode, as it comes up in a demand mode, and thus there is no handshake. I appreciate Jeff joining the discussion, and he pointed that multipoint BFD doesn't introduce any vulnerability and is no different from any other multicast application. I'm not sure whether it satisfied Bob or not. I think that in his updated review, he marked it as still unresolved. Next was that scope of specification that was addressed with an editorial update. And the last point that's still open is incremental deployment resulting from introducing point-to-point value to BFD session type variable. BFD session type variable historically was introduced in multi-point networks, but because this document was worked on for a long time, it ended up defined in seamless BFD document. And because seamless BFD document is kind of standalone, they define the BFD session scope as being only relevant to when seamless BFD is mode enabled. For multi-point networks, the scope of BFD session type variable updated, and it's applicable to 5880 type of BFD as well. So thus, we define the point-to-point session type, new value to session type variable. Again, I provided this explanation to Bob, but he thinks that it's still open. I really don't know how to resolve it. So Mirja, so she had to discuss, and there was a session, several points for discussion. One of them is the volume of traffic that can be generated by multi-point BFD session. Mirja suggested that we limit in multi-hop environment rate of to 1 packet per second. I'm concerned that that will make application use of multi-point BFD really without benefit, because then the detection would be on a single second scale. So we still have this discussion. And she recommended to explicitly call out the limit of BFD sessions at the head, not only on the tail. And text was added to the security consideration section. Next slide, please. Benjamin, so he found very important text missing in a specification in regard to transmitting packet, and added this text. And Benjamin is happy with the change, so basically he is ready to clearly discuss once the new version gets published. Next. Ben Campbell reviewed both multi-point and multi-point with active tail specification documents, and his discuss was more on the process. So why their active tail points to yet to be RFC specification and already updates it. So why we do the update to not yet published document, and he suggested to merge them back together. So we try to explain the history of decision to split the document, but I haven't heard back from Ben whether it will clear his discuss or not.
Greg, Martin speaking. So that doesn't, in my recollection, perfectly reflects Ben's comment. Ben didn't understand why active tail was updating multi-point. And he didn't understand that, especially because the two were progressed at the same time. So what will resolve this problem is that active tail doesn't update multi-point, but that in multi-point you add a reference to active tail.
Did you mean that backwards, that active tail should point to multi-point?
No, multi-point should point to active tail.
There are several references to active tails in a multi-point document already.
That's exactly that's what I told him. And you have even in the introduction some piece of text that mentions it. Mm-hmm. So I think we're clear on that. His only discussion point was do you need to update that document since you're progressing the two at the same time? Do you need the update tag?
Yes, I believe so, because if somebody takes only active tail document, it will have references to multi-point document, and updates basically make it clear that, well, you better read this document as well, because it provides the base, and this document only updates a portion of it.
You can achieve that by normative reference, and you have multi-point as a normative reference to active tail. In active tail.
Okay.
In any case, this is a purely process discuss. I don't think it's critical, and it doesn't change the technology. So not using the update tag is the way to solve that discuss.
Okay. I have no problem with that. And if it would not raise other eyebrows, I will do it gladly.
No. And you might see some statement coming from IESG on the use of update tags soon.
Okay, very good. Okay, so obviously there were many other reviews from Jan Art from Routing Area Directorate, and with the comments not discussed, and those comments got addressed, and everything included in the working documents, working versions of both documents. So again, there are some outstanding questions, mostly to hear back from Mirja and Bob on their position regarding our discussion. And once they agree that the solution proposed addresses their discussed, the new versions will be published.
Okay, great news. And I think that we're likely to see this be the usual, give it 2 weeks after IETF when people have drained their inbox a little bit. And hopefully at that point, these will be closed out.
Okay.
Thank you, Greg. Next up, Albert.
Click the
Declining to display the main page, but first page is good.
Okay, you want to go back to the title page?
The title page is showing blank due to
Okay.
technical difficulties.
All right.
Not our fault.
Good. No problem. Thank you, everyone, for allowing us to go through a particular problem that I consider as a very nasty problem in our network. My name is Albert Fu. I'm with Bloomberg. I'm one of the network engineers there. Jeff Hess, sitting at the front here, is actually the main author of this draft, and he'll be helping me answer some of the questions that you may have at the end. What I would like to do first is to give a bit of a background about Bloomberg Network. So just put some context to the problem that we're having. We have a large global MPLS network. We have more than 300,000 customers that connect to this network. Most of these customers are I consider very important customers. They are the financial analysts. They do a lot of tradings. They look after all the 401k fundings, etc. So they're very critical customers from our point of view. So the network is quite big. I mentioned before, we have more than 1,000 core routers. We have about more than 10,000 CE devices connecting to the network. We have several thousand links spanning throughout the whole continents. So suffice to say that we probably see most of the different types of network problems, dealing with different providers throughout the world. So when we move the network from a SONET type links to Metro E, we have been using BFD for a long time because in the SONET world you have all the beautiful alarms such as AIS, RDIs, etc. that can help you isolate problems very quickly. One of the things we found in our network today with mainly Metro E type connection is that because a lot of service providers use either L2 VPN or pseudowire to provide the point-to-point connection, the last mile is almost always up. So when we have network connectivity problem, we need to find a way to detect that quickly. And BFD has been one of the things that we use to do that. It's been working quite well for many years, except that recently, we had more and more of the smaller providers in different countries providing point-to-point services. This would be going to South Africa, South America, India, etc. And one of the nasty problems that we've seen is Mtu issue, where the interface provided by the service provider can no longer carry the MTUs, a large packet size that we expect it to carry. And when I say large, I'm not talking about giant what they call the 9K packet size in the network. I'm talking about 1,500 bytes, because most of the financial connections that we have, we call the front-end network, we use standard MTU Ethernet packet size, which is 1,500. And because we have an MPLS network, we basically need to support about 1,512 bytes of data. So every now and then we would have links having this Mtu issue. And the nasty thing about this problem is that there is no alarm whatsoever to tell us that we have an Mtu issue. Because as you know, most of the routing protocols such as OSPF Hello, it's less than 100 bytes. BGP Keep Alive is only 59 bytes. And we go back to BFD, which we rely a lot today. BFD packet size is only 52 bytes. So when this problem happens, not only don't we get any alarms of it, it's very hard to troubleshoot, which is one of the points I raised here. Because in our network, we have what's called a typical core distribution and access design, where you have two paths going from the access routers to the distribution routers, two paths going typically from the distribution routers to the core routers. So end to end, typically we have about 16 ECMP paths, 4 times 4. And then sometimes in the core, between the core routers, we have multiple links as well. So trying to detect where the problem area with the Mtu issue is typically quite time consuming. So this is where we believe BFD is going to be able to help us address this issue. There were 2 objectives that we have in using BFD. First is we want to have a mechanism to detect the problem really quickly. So one of the things that we consider was, what about using the existing routing protocols? Can any one of them help detect the Mtu issue? So if you look at the common routing protocols such as OSPF, ISIS, BGP, MPLS, the only one that has padding support is ISIS. In fact, several of the major vendors already provide a configurable option where you can configure ISIS hello padding size to achieve that objective. But the problem with using so not only is it not supported on all the routing protocols, the other disadvantage is that because OSPF or ISIS is run on the control plane, you cannot have aggressive timers to detect fast failure. Typically, we would use default timers, but leverage on BFD to do the fast failover detection. So it's not ideal to use a routing protocol to detect the Mtu issue for that reason. So there are 2 objectives we want to achieve using BFD. First one is we want to have a fast failover detection mechanism. The second thing that we really want to do is we also want to have traffic automatically divert away from the link that has a problem. Kind of the reverse. The third benefit is that when the problem is fixed, we want the traffic to go back to that link again. So it's got that kind of auto-healing capability. So we believe BFD is a good method of helping us address this issue. I think, Rishad, did you have a question you want to ask?
Mahesh Chetanandani. We have talked offline about the problem statement. And one of the questions that I wanted to just follow up and make sure that all of us were clear on was, you mentioned that the issue was that if you kept the MTU 1500 and then it went through a couple of hops of MPLS network, that you would exceed the MTU size, right, because of the extra labels that were imposed. Is one of the considerations that maybe you want to reduce the MTU on all the interfaces down to a smaller value such that it actually accommodated the extra labels that might be imposed?
Yeah, okay. One of the problem with that is that how low can you go? Because the problem in the service provider end, today it might support 1,500, tomorrow might be 1,400. The day after, it might change. So it's a moving target. So what we've done in the network is we assume 1500 is the lowest common denominator facing the edge routers. In the MPLS core, we have X number of MPLS labels that we know we need to carry. So in total, the maximum packet size that we expect is actually just around 12 bytes. So really all we need is a mechanism to check, to allow us to detect that a particular link can support that packet size. If not, we really don't want to use that link, we want to actually mark it down. So this is where we think BFD is a really good mechanism to detect that.
This is Rashad. So when you talk about the link, so it looks like you're talking about single hub BFD. But from when I read the doc, I felt that it was more multi-hub BFD, which was being mentioned.
The use case for us is almost, most of them are going to be single hub. So it will be OSPF between, say, Sydney and US. From our point of view, it's single hub. But what happened is because this day we're using a lot of the Metro E connection, the actual service providers might have MPLS backbone to carry it. So from our point of view, it's single hub. Yes.
So it's one IP single hub. There might be multiple transports or...
Correct.
Okay.
Yes, correct. Right. If there are no other questions, next slide, please. The one before that. Okay, so I just want to go through some of the points which I might have covered. Why do we want to use BFD? Okay, so one of the things we recognize is that all the major service router vendors today support using BFD along with all the routing protocols like OSPF, MPLS, ISIs, etc. The other thing is, if you look at all the major service providers, they also support this ability to do BFD using the line card, or we call control plane independent, in terms of the bit. So this has an advantage that it allows us to have sub-second type failover detection, something that we cannot do using routing protocol itself, such as ISIs or OSPF. So, and the other advantage is that because it's closely coupled with the routing protocols, when the BFD detect the Mtu issue, we could bring the routing protocol adjacency down and direct traffic automatically. There is no user intervention required. As opposed to today, we have to do things manually. When we detect the issue, we have to shut things down. And then we have to put, filters that prevent the protocol coming up. And then we have to do tests to make sure that the link can support the large packet size before we manually go and re-bring the link up again.
Sorry, Matthew Bocci, Nokia. Just a quick question. I mean, you say BFD detecting the Mtu issue, but actually I think you're just saying BFD control packets being dropped.
Correct.
Because they're too large. So you don't actually know if it's Mtu or a failure somewhere.
Yeah, good point. It could be a connectivity issue, but the main thing is we want the Mtu issue to be detected, and three packet drops, and then we would.
Yep.
Yeah.
Understood. Thanks.
Thank you. So one of the side benefits we want is that quite a lot of times we were looking at troubleshooting problems, and the problem just went away. One of the things we always think behind our head is maybe one of the service providers had an Mtu issue, but because we have no alarming capability today, we don't know what actually caused the problem that had appeared to be resolving by itself. So using this with BFD would give us a mechanism to generate alarms, and we can follow up with the service providers. So we go to the last slide. So what I would like to do now is to go through the proposed solution to address this issue. If you look at the best BFD standard today, there is a 1 byte BFD packet length, which obviously can support only up to 255 bytes. So that field itself is not sufficient to achieve the objective we want, which is around the 12 bytes. And some other customers might have different requirements depending on whether they have, the number of MPLS headers, labels that they expect to send, or if they're using segment routing or VXLAN, the packet size might be different. So what we're suggesting to do is we want to have a mechanism, we would like to have a mechanism at the IP layer to pad the BFD packets. So at the BFD packet is typically about 52 bytes, being 24 bytes of the actual BFD packet plus 8 bytes for the UDP and 20 bytes for the IP header length, so 52 bytes. So what we would like to do is at the IP layer, pad it up with a configurable number of bytes so that the periodic BFD packet that's being sent out, it's a large packet padded with either 0 or in the standard we talk about 0, but that could really be any bytes because we have a good CRC mechanism that could help to detect if there's any bit type errors on the link. So in terms of the two, we have two different networks where we have use cases. So I have a little table at the end. In the pure internet core network where we only have IP traffic, the maximum IP packet payload is 1500 bytes because the BFD packet is 52 bytes. We would configure the padding size to be 1448 bytes. In another part of the network that we have L3 VPN traffic where we have up to 3 MPLS labels, each label being 4 bytes. So the actual, because we need to carry IP packet size up to 1500 bytes, the MPLS payload is 1512 bytes. So in that case, we would subtract 52 to get 1460 bytes for the padding size. So those are the two use cases that we would be able to take advantage of, if this feature is available. So in summary, yeah, please go ahead.
No, finish your summary. I'll ask a question at the end.
Yeah. So we feel BFD is a good mechanism to allow us to achieve two objectives. One is fast failover detection. The second thing is we want traffic to be automatically diverted away from the link that has the Mtu issue. Plus the added benefit is that when the issue is resolved, BFD would come back up again, and then we don't need to have any user intervention to bring the service back into operation.
Hi, Rick Taylor. I really like the direction you're going with this. It makes a lot of sense. How, and this may be a very naive question, how do you see this interacting with the do not fragment header bit? So, yeah, you're trying to send a frame that's far too big. You set DF. Are you intending to do anything with the ICMP response? You're talking one hop here anyway, so you're going to get it. Is the interaction between this and Path MTU discovery?
We're obviously stealing an idea that's already out there.
Yeah, absolutely.
That said, BFD doesn't normally pay attention to anything outside of its other layers if it can get away with it. Well, certainly it could pay attention to ICMP. I think we all sort of expect, especially in the networks that Albert's likely working in, that ICMP might not even get through, especially since there may be a couple of tunnels in the way. BFD itself will notice that things are not working just because the packets are big and they're not coming back. So ICMP interaction might be an interesting thing to look at, but I don't know that's a core necessity.
Okay.
And just to pause the discussion for a moment. The whole point is to have a discussion at this point forward and see what we can go along by. A quick process question. Who has not signed the blue sheets? Thank you. So as I mentioned, the goal at this point now is to have discussion about what do we do about this. The draft that Albert and I have put together is just covering the simple idea, throw some packet padding at the end of things. This is, I think, sufficient to do part of the job. There's a lot of open questions even with the initial proposal, and those include what should the padding be. Some people have actually suggested some machine patterns that might be better for detecting certain types of link failures. We've also had discussion points about, in the case of ECMP, this is BFD, we're not necessarily exercising all member links. We're not saying we have answers. We're not saying that we're tied to any specific thing. What we're really looking for is open discussion. We will be looking for probably doing an adoption call after this IETF, and I'm speaking as a contributor rather than a co-chair. And we really invite the working group to help work on this problem.
Yeah, Naiming Shen, Cisco Systems. And you mentioned using the BFD to have a faster failover. and even considering the control plane is maybe too slow, and this is fits for the data plane, all those things. But I would think normally the BFD detection is detect a link failure, all the traffic will be lost, right? For the MTU issue, I would think normally it does not change that often, right? When you have a provider or several providers out there, we don't need such a fast detection. I would think it's a very good idea to have the BFD, to have the MTU detection. But I would suggest to use something similar to the authentication. You do this occasionally. You don't need to hog the link all the time with such a fast pace. And in particular for people like paying a huge amount of money for LTE link, sometimes you also need to have BFD running on this. You don't want to have a large packet all the time. That's my point.
Yeah.
Thank
so good points, Naming. So just coming back to your second point, the timer that we would use would be exactly what we would normally use in today when we run the whether it's BGP or OSPF. The comment that I have about fast failover detection, it's really in relation to the fact that if you look at the routing protocols today, such as ISIS, we really cannot go low with those sort of protocols because it's control plan. We have an internet flag with 700,000 routes. We don't want those false alarms to come on. So that's really kind of the point that I'm saying, is that it has the ability to allow you to have fast sub-second detection. And certainly in some of our environments, we would actually have that. And in fact, we're looking at the deployment right now where we're looking at using BFD interval of 100 milliseconds because, there is a particular, application we want to make sure that we have sub-second type convergence. And having that ability to have that detection mechanism is a good thing to have. Second, the first point that you mentioned is also really valid. This problem doesn't happen a lot. In our network, we probably see it, once a month. The problem we have is that when it happens, it's really tedious and time-consuming to detect and trying to troubleshoot it. So we really looking for a method that can automatically detect and resolve the issue. So I just want to go through and, obviously we want to do something before the standard comes out. So one of the things we're doing today is that we actually have a scripts that goes onto all the routers and periodically ping. So we intentionally change the MTU size on the link, and then we intentionally ping up to the largest size that we want. And then when that packet doesn't go through, we're going to generate an alarm. But, as you know, ping is a control plan activity. So you can't rely on it. Sometimes when the ping fails, it doesn't mean there is an MTU issue. But then again, you might have a connectivity issue. So we need to go back and do ping with a small packet size first. Check and see if the small packet size goes through. If the small packet size is getting through, but the big one is not getting through, then we know that it's likely to be an MTU type issue. So, and now on some of the routers, we have about several hundred links. So to go through a cycle, and then imagine you have, close to 1,000 routers where you have to do this. The cycle itself is about 15 minutes just to go through the iteration. So the detection time today, while we can detect it, it's quite long. So we're really looking for something that's simple. Sorry, I keep you waiting.
Justin Sura.
Actually, one moment. Greg, you are fourth in queue behind Mahesh. Please go ahead.
Thank you.
So I see where you're coming from, and if it helps you to solve your problems, all in. Kind of supporting what Naming said, if you look at modern NPUs, probably 90% of them have OM functions implemented as dedicated block. And they run up to 3.3 milliseconds. So if you start building packets of 1,500 bytes, most probably it's not going to work or it's going to kill your performance. So you would really carefully look at minimum interval you are going to use your feature for. Maybe talk to Ilya, Broadcom guys, I don't know, who else is Nokia, Juniper, and figure out probably running at around 1 second interval and doing slow BFD. So when we use it across multiple line cards, sometimes terminated on the RP, to offload this functionality from dedicated NPU block to something more centralized, more generic might be a really good idea. So probably if you look at 10 millisecond convergence or detection, it's not worth doing it. You should be somewhere around 1 second, I think.
All right.
And to respond to that, we're not proposing any specific timer. Talking to our own internal BFD team, we do know that we just simply cannot run the exact same scale for 52-byte packets as we can for 1500, even if the portion of the CPU that catches the BFD packets doesn't get anything other than the 52 bytes.
So I think it would be important to include operational considerations in the draft, just stating we know there's particular limitations to most of implementation, and we think this is what would be, what's the right word, would be wise to do.
Practical, right? Practical timers. Okay.
And you would help other people who are going to use it after you.
Yeah.
It's a good solution to your problem.
Yeah. So one other point I just want to touch on is you mentioned OAM. So we did actually look at OAM as well. Oh, okay. I was thinking about the the Metro E OAM. One of the things we found is that if you look at in our case, it's really CFM we're looking at. Not all service providers support. Not all Metro E providers support OAM. So BFD is ideal in the sense that we know it's going to be supported because it's IP.
So to clarify, I wasn't talking about layer 2 OM. I was talking about logical block on the piece of silicon that is producing fast hellos. So including CFM, including BFD, anything that goes sub 100 milliseconds.
Okay, thank you.
Rashad Rahman from Cisco. A couple of questions as contributor. One is this you mentioned is for single hop, so BFD Echo would do the trick. I mean, if you don't support BFD Echo, then you need this, but BFD Echo being proprietary, you can do this 100% with BFD Echo, I believe. Jeff, correct me if I'm wrong or right.
Mm-hmm.
Oh, you're absolutely correct.
Okay.
And for the cases where the Echo would be applicable, this does make sense. And actually, one of the things that's in the document was some reference to work I had previously done a few years back. Xiaomin, if I remember right, specifically about using BFD Echo with a probing format, literally just simply hitting packets at a step function until you found where the actual failure points were and using that as a reporting function back. That that proposal itself could be used in this type of case as well. I think where this becomes a little more interesting as a generic discussion is Echo can only really be used in a single hop environment.
Yep.
And we're looking at, as I mentioned, we're looking at this not only in the single hop. Albert's looking at this very much as an end user. He gets basically a circuit from his customer and just expects it to work. And as far as he's concerned, it's largely just a normal IP circuit. He doesn't care about what's underneath it. Whereas a number of the people in this room are building these circuits out of things like MPLS, EVPN. If you go back to really old stuff, people did frame relay. But just all sorts of kinky technologies that are involved. When we start looking at the general problem, if you're building these ECMPs, for example, and providing a single plug-in circuit to the customer, you have to worry about how do you load balance this over multiple things. You can't do that with BFD Echo because that's using the forwarding plane. You might be able to do it sort of like BFD for lag by intentionally using the L2 to inject it on subcomponent links. So this is a discussion point. So there's. I'm not saying Echo is out of scope. I'm not saying async solves all the problems, but there's definitely a problem space we have to figure out.
Yeah. Okay.
Can I just add one more point to your discussion? So we did look at that as well. One of the problems we found is that if you look at the top 3 router vendors today, only one of them support Echo mode. So, and we have all the 3 router vendors today. So the commonality for us is really to use the pairing method.
Okay. Yeah. So next question is, how do you intend to, what you guys thinking in terms of advertising this capability? Because obviously, if you use that at one end and the other end has some checks where the padded packets are dropped, then you will have an issue. Are you guys considering like IGP extensions or configuration?
I was just going to comment that as a users, we know, it's a bit like running certain features between two routers.
Okay.
If we know both routers support it, we would enable it. So in terms of us doing provisioning ourselves, we would have certain flags that say this, in our network today, it would be, one or two vendors. So that's very easy to do.
Okay.
But in terms of the, if that packet is sent out, we know it's supported, then it should work. In fact, I would almost care to say that even if you have one that's supporting that, but the other one doesn't, as long as the implementation at the other end does not treat the pairing bytes differently, they just look at the UDP packet payload is still 24 bytes. So I think it depends on how the implementation works.
Some implementations might drop it, I think. Yeah.
Yeah.
Okay, so
it would be,
okay.
Just to answer your question, it's a bit like us configuring features. We would enable it only on devices where it's supported on both ends.
Okay, so there might be Yang model extension at a certain point.
Oh yeah, and this is absolutely, we are definitely abusing the fact that you can stick a little tiny packet inside of a big one. We know this just happens, and implementations might be pedantic enough to drop them. One of the things that we sort of had in our back pocket for a while as a BFD extension mechanism is the Daves, when they were doing BFD, had experience with OSPF, obviously. And OSPF's authentication mechanism actually went into unused space at the end of the OSPF packet inside of the IP packet itself. That's how they managed to wedge it in there. So the technique's been used before. It's entirely likely that this might even be a reason for us to finally push the button and go to BFD v2. So we're not saying this is the solution. There's a lot of places talking around here, but obviously we push that v2 solution, and we sort of open up the gates to a lot of other things.
Okay.
And also in terms of the implementation, we'll be looking at this configurable on a per neighbor basis. So on each link, so it's not going to be a global where it works on some and not others. So
okay.
Thank you.
Thank you.
Mahesh Chetanandani. So I'll try to make 2 points. I think one of them, I believe Jeff has kind of alluded to a couple of times already, and I know it has happened in your private discussions. And that has to do with hardware platforms having to now deal with a 1500 byte packet. So if they have special ACL rules or whatever there to redirect packets for special handling, now you have a case where if the platform is able to support now, they won't be able to support BFD at all in this case. So that's another operational consideration point to be added. The second point I wanted to make was I think I like the idea that naming mentioned, which is the occasional large packet. And instead of trying to stipulate a certain interval that you should only send it, and also consider the fact that maybe you might want to send this 3 packets which are of large sizes to just make sure that the link is still operational from your point of view, whereas the rest of the packets maybe can be of smaller or the regular size.
Okay.
And to sort of go back to the proposal I'd worked in with Xiaomin. Since we were using Echo in that proposal and we were doing it as a periodic thing, the goal was not to take the session down. We actually wanted to use it more like the BFD performance draft. We wanted to actually treat it as do it occasionally, and by noting that something's not getting through and we expect it to, use that to raise an alarm condition without
That's
necessarily.
True. That's even better suggestion. Yep.
And Greg, I'm pushing the speak button.
Okay, thank you. Yeah, actually, I had the suggestion similar to Mahesh that resembles our discussion on optimized authentication to use a series of large packets intermittently, so sending them and then going back to the normal size. But I wanted to bring to your attention, you might be interested to look at minutes or listen to discussion at BEER, where they discuss proposal BEER MTU discovery from Stig Venus, and had a broader discussion of usability of path MTU discovery protocols. What's interesting about Stig's proposal is that he proposes to have aggregation of the main MTU and advertisement of MTU by through IGP. Another point that I wanted to ask is that if you intend to use multi-hop BFD, how would you ensure that the BFD session follows the same path as your data flow if you have ECMP environment? So basically, that MTU that you are monitoring is the same MTU that as your data flow experiences.
Yeah. Can I comment on the 2 points? The first point about advertising the IGP, the MTU to the IGP, that's actually what I call a control plane type signaling rather than actual data plane. What we're suggesting here is that we actually want to make sure that we can physically send out the large size packet, not what we think can be supported. The other point is about the path MTU. One of the things we also want to be conscious of is we do actually want to try to send 1500 bytes packet size in our network. We don't actually want to use path MTU to reduce the packet size when we don't have to. The reason is because it has implications on the CPU utilization on the servers that we have. You know, some of them have they're processing like several 100,000 transactions per second. So we really want to try. It's kind of in our interest to make sure that we try to send 1500 bytes as much as we can without going down smaller. If the link cannot support that, we want to make sure we like to have a mechanism to bring it down because we have a lot of redundancy in our network.
Actually, since you mentioned that you want to be guaranteed that this path can sustain, so I would probably envision that you will be running this MTU monitoring proactively on all your physical links. So yes, then the question is, since BFD follows the best route, how would you ensure that you are monitoring all possible paths proactively before switching to the protection?
Yeah, so good point, Greg. I didn't quite answer your first part. So the point that we want is not to actually detect exactly where the problem necessary is, except in the case when you have a single hop BFD. In the case when you have multi-hop, you're right. We would not be able to know exactly where the problem is, but at least it would tell us there is a problem. And then the fact that we have an alarm coming out saying BFD has gone down, give us a clue that there is something that's not right and we should go and do some investigation. As opposed to today where we're kind of in the dark waiting for things to happen and then we have to go and try to troubleshoot, which is quite tedious, especially when you have lots of ECMP paths.
Right, and actually that's where I kind of have a question, but we can take it to the list if we are out of time, that in multi-hop use case, to guarantee that your BFD follows the same path as your data may be a challenge.
Thank you.
Yeah, Rick Taylor again. Following on from what Greg was saying, of course, because you're effectively in an overlay network and you're testing the MTU of your overlay network. In multipath, of course, there's no way to realize that you might be going across an ATM link in your underlay that's therefore fragmenting and reconstructing your packets along the way. I suppose that doesn't really matter in your use case because you're getting 1500, but yeah, it's just one of those other little complexity things. I'm not sure that I've got a problem there, but
yeah, and part of the thing is by having this idea at least present, the rest of us, when we're actually building the devices and the protocols using this stuff, can make use of this mechanism to, if we're asserting that you're getting a CPE link of 1500, that it's actually being provided. And similarly, like if a component link all of a sudden goes out and starts signaling that only can support 1400, you can knock it out of the lag as an example.
Unrelated, but the second point was about the loading involved with having the full-size packets going down the wire. It would make sense to me to have a secondary timer where you're doing that very fast, small packet stuff, just to make sure your link is there. And maybe a couple of pulsed not jumbo, but a couple of pulsed bigger packets, just checking you've still got your MTU you're expecting might be a nice balance between the two. So you know your link's there, and then you can do that second check and it is the link I want to use because it's meeting my requirements.
I think that's a good point. We obviously need to take practical implementation into consideration when we come to actual deployment.
Sorry, Matthew Bocci, Nokia again. So yeah, I think in general this is a good idea and it's a good thing to do. I'm a little bit worried about the complexity of bursting the big packets and then falling back to small packets. I can see situations where you might end up with BFD sessions flapping because it will go down because when you send the big packets because the MTU has gone down, then you try and come back up again and you're maybe coming back up with small packets, but it comes back up because it gets through the MTU. It creates some, you may end up with some bouncing of the BFD sessions there. So I don't know, maybe we should need to think about how complex this is going to make the state machine.
Yeah, good point. So you have to miss 3 packets for the BFD session to go down. So some vendors have this mechanism that allows you to do BFD dampening, which is something that we're using today. So if BFD goes down, we have a timer that says when BFD comes back up, wait up to 60 seconds before you bring the client routing protocols up. So that kind of get around that issue where you might have flapping situation. So we would, in fact, this is similar to the interface, the debounce timer or hold time that you have, where when the interface goes down, when it comes up again, we don't actually use it straight away. In our network, we actually make sure that it's stable for X number of seconds before we put it into operational.
Rick Taylor again. Thinking about, as was just said by Matthew, about the big frames tearing down your session and then coming back up. I can't remember the name of the draft or if it's actually an RFC with the sequence numbering in there. You could intersperse to make sure you're sending out packets faster than your timers expire. So, okay, I missed my jumbo frame. No, I don't stop saying jumbo frame. I missed my big packet, but I got sufficient small packets to keep the session up. But I've detected the big packets didn't get there because they don't have the even sequence number or whatever I'm sending on. So I think there are ways to work around the flap, but I think the flap should certainly be in the considerations. So.
Okay.
That was excellent discussion, and I guess we have a little bit of excitement around the feature, so we'll definitely be poking this on the mailing list. This was the last agenda item, so if there's nothing else people are interested, it's 4:52. We'll see you at the next session in Bangkok.
Thank you, everyone.
That's right, they missed that. I suspect that there's a 50% chance that okay. I know that was just before I were all conversating. Yeah.